Diana always told me, just go get it, go get them. In fact, I have a sign that says, go get them, as I walk out the door. And you know, when I look back, Diana will have always been that person who encouraged me, who taught me how to do good science, and who taught me to think outside the box, to really challenge myself and not be afraid to have that crazy thought that I could, for example, get a drop of saliva and I could have a window into how that baby's brain's developing.
She had this vision for non-invasive prenatal testing. She saw the future in a way that others just simply didn't see. And she stuck with it, and it is to her credit that this is becoming a reality now.
Reducing invasive testing by over 60% worldwide, that kind of research has been groundbreaking. It's not often in a career that you can really change the way medicine is practiced.
She's clearly fulfilled all the promise that we as scientific parents saw back then. And that's a lovely thing when that happens. Diana is one of the most prestigious in terms of where she's taken her life, insightful in terms of what she knows about and has chosen to learn about, and gentle but strong.
I'm very proud of the fact that I'm a first-generation American. My father was an Italian immigrant, came to the United States when he was 30-something, and my mother was born in Berlin, came to the United States during her early childhood. I grew up in New York City, in Manhattan, went to Hunter College High School. One of my early inspirations was my teacher, Mrs. Anita Wells, who taught me high school biology in 9th grade. I worked in a cytogenetics laboratory at Roosevelt Hospital in Manhattan and wrote a thesis in my senior year of high school. And there I was introduced to early genetics, and importantly, I met 2 female pediatricians. And it was at that point that I began to think, wow, you know, medicine is interesting. I was always interested in science. So I remember making a conscious decision to select the University of Pennsylvania because they had a medical school right on the campus. They also had a human genetics department. For all 4 years of college, I worked with various people in the Department of Human Genetics, including at the Children's Hospital of Philadelphia. I was very interested in advancing knowledge and using that to help people. Stanford was a medical school that encouraged research. I had a difficult decision between obstetrics and pediatrics. I loved the idea of childbirth, of pregnancy, of the developing human. But at the end of the day, I found that I was always checking in on the babies, not so much on the mothers. And it really came to a head in my 4th year at Stanford when I did a sub-internship in the neonatal intensive care unit. In the delivery room, it's so intense and it's so primal at the same time. I mean, it's the beginning of a new life. It's, you know, these babies, they need to breathe, they need to be resuscitated, and it's truly life or death. And to be present when a family is becoming a family is such a privilege.
She was in the Department of Pediatrics, which was not our department, but Howard Ken ran into Diana and said, she's really, really good. She's a very bright medical student.
And he said, oh, you have to meet the Herzenbergs.
Len and I ran the lab together. He liked the somatic cell genetics part, and I liked mouse immunology and understanding the genetics of the immune system. Howard recognized that Diana really, should have a lab like this.
The Herzenbergs had a son named Michael who was born in about 1959 or 1960.
We had a child, Michael, who was recognized immediately as being Down syndrome. And we realized that wouldn't it be wonderful if you could do prenatal diagnosis, if you could actually take a sample of the mother's blood and know whether the baby was going to be Down syndrome rather than getting him as a surprise, as we did.
Len had only a few years earlier essentially invented the fluorescence-activated cell sorter, or the fax machine.
His feeling was you couldn't do biochemical genetics unless you could separate the cells that did something from the cells that didn't do that.
Len said to me, we'd like you to develop a non-invasive prenatal test for Down syndrome using the fluorescence activated cell sorter. And there's something about being, young and naive and feeling that you could do anything. So I didn't actually realize how difficult that would be.
And Len's suggestion was that she work with Mike Iverson and with Jim Schroeder, and we actually get this project underway.
And she approached it by saying, well, if we could only get at those fetal cells, if we could see them, and if they were circulating in the mother's circulation, then we could look at the chromosomes, and that would give us our answer.
Part of what I did was drive around the Bay Area to pregnant women who were willing to be in these studies, and then at their homes, I drew their blood and their husband's blood so we could identify the fetal cells on the basis of the fact that they had inherited a protein from the father.
To identify a fetal cell or a couple of fetal cells against millions and millions and billions of maternal cells was such a daunting task.
And this is often true with the medical students we bring in, that they may not have the knowledge to do what they want to do, but they have the fire. And it keeps everybody excited about pushing on something which is so difficult, and you do it, and you do it, and you do it, and it doesn't work. And finally, you find out how to do it so it does work.
By the end of medical school, we were able to show with statistical significance that we were able to physically isolate these cells from the blood of pregnant women.
That was what you needed to know in order to take the next step, which was to find them and do the diagnosis.
Basically, it took from approximately 1974 until 2011. It was a combination of a number of things. This recognition in 1997 that the DNA was floating in the blood of pregnant women, but also the technological advances that allowed the DNA in the blood of pregnant women to be sequenced. And this is work that Stephen Quake was also working on at Stanford. The research, not in a straight line, but with some deviations, eventually led to a very precise, non-invasive prenatal screening test for Down syndrome.
Nowadays, it's estimated that worldwide, upwards of 3 to 5 million pregnant women each year will be getting non-invasive prenatal testing.
The final chapter of the research is really, now that we can accurately diagnose Down syndrome non-invasively, what can we do about it? And can we offer families an additional choice? And again, it's one of these things that 10 years ago I would have said, this is crazy. But we have preliminary evidence to suggest that we can improve brain development, learning, and memory in fetuses with Down syndrome. And by doing so, you get a very big improvement in independent life skills.
What Diana realized very early on is that the mother and the child are intricately linked, as well as the placenta. And you cannot separate the three. In fact, you must consider them as a whole in order to truly advance the field of maternal and child health.
I ended up going to Boston Children's for 3 years of a pediatric residency. Dr. Latt was my mentor. We made the surprising discovery that the fetal cells actually stay in the mother's body for decades after delivery.
She coined the term fetal microchimerism, or the concept that these fetal cells become part of the mother herself.
We saw evidence of the fetal cells in the thyroid of a woman with thyroid disease. We saw it in a woman who had hepatitis, and it really led us to the concept that the fetal cells could be participating in the reaction to disease and hopefully helping the mother recover from the disease. So that was pretty profound.
Diana and I met over 30 years ago when we were residents together at Boston Children's Hospital. And leaving Harvard and coming to Tufts, I think she saw the opportunity to build her own genetics program and her own vision.
Diana realized there was a knowledge gap here and there was an opportunity to really improve how we approach maternal-child health. And her brainstorm was the Mother Infant Research Institute, or MIRI, which she founded in 2010 at Tufts Medical Center. At the time, it was the only research institute in this country that was devoted to both the health of the mother and the child.
You know, when you talk about research within pediatrics, you always started with Diana and her research program. And yet, probably one of the best things that she ever did in her 25 years at Tufts is recruiting and training really young, talented people who've gone in and continued in academic medicine.
One of the exciting aspects of being able to train with Dr. Bianchi was, at times it was like the United Nations. I mean, people should understand, people came from around the world to be able to train and learn from Diana.
I feel it's extremely important to mentor the next generation, and particularly being a woman as well, it's very important for younger women to have female role models.
She taught me so many lessons, not just about science, but about life and what this journey really is about to be a physician scientist.
There are certain trainees who call me their science mom, and I love that.
Here was really a true role model who never gave up, who kept going, who would allow herself one day to feel sad and say, well, now we best get back to work. And I still try as best I can to take that approach in my own life and now as a mentor myself.
The fact that she was such a strong clinician and such a wonderful researcher and so politically motivated, it's rare that any of us spend a day without thinking about her and her ultimate contributions. Over those 25 years, she played a very important role in women in medicine. She was the editor-in-chief of prenatal diagnosis. Her textbook, Fetology, was a worldwide text that everybody used, and yet I still knew her as Diana, very down-to-earth, very humble. And then on top of everything else, she applied for and received this position as the director of the National Institute of Child Health and Human Development, arguably becoming one of the most important pediatricians in the entire world.
When I heard that she was the candidate that was selected, I was like, oh my goodness, does that make sense?
There's something to be said for raising your hand and swearing to protect the Constitution. You can't do this without a very supportive spouse. And my husband, he's actually a very large football player type, but he's a nurturer. And the fact that he's a nurturer has really allowed me to do what I do.